Good morning, everyone. Today I'm going to start the unit 2 of Introduction to Machine Learning, that is descriptive statistics. So, what is statistics? You already know, you have studied. The statistics is nothing but the science of collecting data and analyzing them to infer proportions, that is sample, which are representative of the population. In other words, we can say that statistics is interpreting data in order to make predictions for the given population. And coming to the branches of these statistics, we have descriptive and inferential. This descriptive statistics, it is nothing but a measure that describes the data, whereas inferential statistics, it is using a random sample of data taken from a population to describe and make inferences about the population. So we are going to discuss in this unit about the descriptive statistics. That is the measure that describes the data. What is this descriptive statistics? It is nothing but the summarizing the data through certain numbers like mean, median, so as to make the understanding of the data easier. It does not involve any generalization or inference beyond what is available. This means that the data is descriptive statistics are just the representation of the data available and not based on any theory of probability. Data. So whenever we use the word data, we refer to a collection of information, maybe either in an organized or unorganized format. So what is organized data? This refers to data that is sorted into rows and column structures where each row represents a single observation and the column represents the characteristics of that particular observation. And the unorganized data it is in the free form, usually text or raw audio or signals that must be parsed further to become organized. And coming to the representation of data, the word data refers to constituting people, things, events, ideas, and it can be a title or it can be an integer or any cast. But after collecting the data, the investigator has to condense them in a tabular form to study their salient features. So such an arrangement of data is known as the presentation of data. So how we are going to present, how we are going to represent that particular data is in a tabular form or maybe it is graphically. So this arrangement of data is known as the data representation. So let us see in how many ways we can represent the data. So here let me explain you with one example. Here there are some marks of 10 students in a particular class. Out of 50, according to their roll numbers, maybe these are the 39 to 50, these are the marks. Now, this data, whatever I am presenting here, is known as the raw data. The above given data should be placed in a serial order to make it into an organized data. So how we are going to do? Just create a table where the rows consists of the roll number of a particular student and marks. And the columns describes the roll numbers 1 to 10 and their marks respectively. So now you can say that this data is an organized data. This is one way to represent the data. Let us see the types of graphical data representation. How we are going to represent the data graphically. The very first one is bar chart. Bar chart helps us to represent the collected data visually. So it can be visualized horizontally or vertically in a bar chart like amounts and frequencies. And it also helps us in comparing different items. By looking at all the bars, it is easy to say that which types in a group of data influence the other. See here one more example. Let the marks obtained by 5 students of class 5 in a class test out of 10 according to their names be like 7, 8, 4, 9, 6. And the data is the raw data. And the above data can be placed in the bar chart as shown below. Let us make it into organized structured data, names, and their marks. Now, how we are going to represent it with the help of a bar chart. So the chart, the graphical representation generally it consists of a x-axis and y-axis. So in the x-axis, we are writing the names of the students and y-axis represents the marks. So by seeing this, one can identify that Akshay has got 7 marks. Maya has got 8 marks. Means it's very easy to analyze the data if a data is represented graphically. So this example shows it is a bar chart. A bar chart representation will be something like this. Next one is histogram. Histogram is also a graphical representation of data. And it is similar to the appearance of bar graph, but there is a lot of difference between that histogram and the bar graph, because bar graph helps us to measure the frequency of categorical data, whereas histogram is used for quantitative data. So in the coming slides, I'll explain and I'll make you clear what is categorical data and quantitative data. So see here, this is in x-axis the height of a particular person, and this frequency shows the as per his age. If it may be inches, okay. Is if the particular person is 0 to 5 years, okay, maybe his height may be in the range of this, like that. For a particular person height and according to their age, this representation, if there is a change every year, okay, for every aspect, then we can say that representation will be given by an histogram. So which is using to the types of data. There are 4 types of data, that is nominal, ordinal, discrete, and the continuous. So this session we are going to discuss about the data. Why? Because the further concepts we are going to analyze based on this data. So today everywhere we hear the data. Data is, we can say, it is the new oil. Whether you are a data scientist, marketer, businessman, or analyst, researcher, or if you are person in any other profession, we need to play or experiment with the raw or structured data. So this data is so important that it becomes important to handle and store it properly without any error. So while working on these data, it is important to know the types of data to process them and get the right results. So mainly there are 2 types of data. One is qualitative and other one is quantitative data. And both of these are further classified into 4 categories, that is nominal, ordinal, discrete, and continuous. Let us see the graphical representation of these types of data: qualitative, quantitative, and further divided. This nominal and ordinal comes under qualitative, discrete and continuous comes under quantitative. So let us discuss one by one. Qualitative or categorical data, as the name itself indicates, categories. It can't be measured or counted in the form of numbers. These types of data are sorted by category, not by number. That's why it is known as the categorical data. The gender of a person, the color of a person, like all these things comes under qualitative data. This data helps market researchers understand the customer tastes and then design their ideas and strategies accordingly. The other examples, qualitative data: what language do you speak? If I ask a question, what language do you speak? You'll simply give an answer, maybe Telugu, Hindi, English. So it's nothing but categories. These 3 different types of categories you can speak. And favorite holiday destination, opinion on something, is agree, disagree, or neutral. Colors. So these are all comes under the qualitative data. And the qualitative data are further classified it into qualitative or categorical data, are further classified it into 2 parts. One is nominal data and other one is the ordinal data. So nominal data is used to label variables without any order or quantitative value. Okay, the color of hair can be considered as one nominal data. And the name nominal comes from the Latin name nomen, which means name. With the help of nominal data, we can't do any numerical tasks or can't give any order to sort the data. And these data don't have any meaningful order. Their values are distributed into distinct categories. Let us see the examples of nominal data. By seeing this, you will come to, you will be clear what is this nominal data. Color of a hair. You have this many colors. So it is nominal. Marital status. We ask a person, maybe he'll say single, widowed, or married. Then nationality. If I ask you a question, nationality, you give an answer as Indian. So it is a nominal. Gender. If I ask what gender, male or female. Eye color. So these are all nothing but the examples of nominal data, which can't be measured, which we can't do any numerical task. Okay? And other one of this qualitative data is ordinal data. Have natural ordering, okay, where a number is present in some kind of order by their position. Okay, But these kinds of data can be considered in between qualitative and quantitative data. And ordinal data is qualitative data for which their values have some kind of relative position. And compared to nominal data, ordinal data have some kind of order that is not present in the nominal data. So let us see these examples. When company asks for the feedback, experience or satisfaction on a scale of 1 to 10. So if I ask the feedback about myself and I'll ask to grade between 1 to 5, then you will give either 1 or 2 or 3 or 4 or 5, not all at a time. So that is nothing but the ordinal data. And grades, you will get the results and you will see the grades. You will get either OS, outstanding, A, B, C, D, E, and F. So this is also a ordinal data. And ranking of people in a competition, first, second, third, economic status, like high, medium, low, education level, higher, secondary, primary. These are all nothing but the comes under the examples of ordinal data, which comes under the qualitative or categorical data. And this is a difference between nominal and ordinal, can't be quantified, gives some kind of sequential order. It is qualitative data or categorical, but it is in between qualitative and quantitative. And it cannot be used to compare with another, can help to compare one item with another by ranking or order. And these are the examples I already discussed. So this is the difference between nominal and the ordinal data. And the next one is quantitative data. It can be, the word itself indicates it can be expressed in numerical values, making it countable and including some statistical data analysis also. These kinds of data are also known as numerical data. It answers the questions like how much, how many, and how often. For example, if I ask the price of a phone, the computer's RAM, the height or a weight of a person, all these falls under quantitative data. Okay, and used for statistical manipulations. And these examples of quantitative data, you can see that height or a weight of a person, room temperature, every time it won't be at the same time, scores and marks, and the time. So these are the some of the examples of quantitative data. And this quantitative data further classified it into two parts, that is discrete data and continuous data. So the term discrete means distinct or separate. And it contains the values that fall under integers or whole numbers. So if I ask the total number of students in this class, it is an example of a discrete data. And these data can't be broken into decimal or fraction values. Yes, if I ask you at this time, it can't be broken. And these discrete data are countable and have finite values and their subdivision is not possible. Okay. So examples of discrete data, total number of students, cost of a cell phone, number of employees in a company or the number of faculties in NGIT, the total number of players who participated in a competition and the days in a week. So these are all some of the examples of discrete data. And next one is the continuous data. So these are in the form of fractional numbers. It can be like version of a phone, height of a person, length of an object, which is a fractional numbers. Yes. So continuous data represent information that can be divided into smaller variables and it can take any value within a range. So the key difference between discrete and continuous data is discrete data contains the integer or whole number. Okay. Discrete. Continuous data stores the fractional numbers to record different types of data like such as temperature, height, width, time, speed, etc. And these are the examples of continuous data. That is height of a person, speed of a vehicle, time taken to finish the work. And if you take the frequency of a Wi-Fi and market share price daily, it won't be at one place. So these are all nothing but the examples of this continuous data. And this is the difference between discrete and continuous data. So discrete data, I already told you, it is countable and finite. And these are measurable. These are represented by discrete data measurable by bar graphs. And it is represented in the form of a histogram. And these values cannot be divided into subdivisions. But here the values can be divided into subdivisions. Discrete data have spaces between the values. Continuous data are in the form of a continuous sequence. And these are the examples of discrete data and the continuous data.